Hello, guys. Hello, girls. It's good to be back. We're back with another episode of Fun with Modern C++. This is the second part in the series. I know it's been a while. I've been rather tied up for the last couple of months, almost going to 7, 8 months on some project that couldn't allow me to continue with these. But now I'm back, and I'll encourage you guys to like the videos, to subscribe, to share, so that we can get this thing back on track. If you want me to spam these things, so just hit that like button, and I'll know that we can push these things out uh, without any further delays. So there's plenty of content coming up over the today and the next couple of days. So we resume from where we picked off. Last time we looked at an example program. So if you didn't start off with that first episode, I would advise you guys to go down and take a look at the first episode. The link is in the description below. And before kicking off with this, so today we're not going to do actual coding. We're just going to be looking at fundamental types. These are important where before you actually go into the coding of C++, these are just basics that you need to know. So this is the best time. We'll just get through with these, and then we'll look at some of the preprocessor directives next time, and then we can jump right into the interesting part of C++, which is the code. Now, so as far as the fundamental types go, there are a couple of there are a couple of them. So we'll just start off. There's the void type, which um, which is basically a set of values where you want to have a function or something that doesn't return anything, um, or something that points to nothing, a void space, such as the standard null pointer, or when you have a function you source with the function int main, and int main returned an integer, which in this case we were returning 0. With void, you return nothing. That is useful if you just want to change data in memory, or you want to print something to screen and not necessarily return any type. So that is what we use, and we will be seeing that later on. Then next is the bool, which is a Boolean type. So here's an example where it's a bool lights out is equal to true. It can either be true or false. In other languages or in other ways, historically it has been either 0 to represent false and 1 to represent true. But in this case, the keyword true and false is accepted in C++. It's the way to go. It's what is used. And then moving on next, we have, sorry, that Boolean type can also be used to, as a function return type, as well as the void. Then we have the character types, which is for character representations. That is such as the letter A or symbols, numeric characters, and usually by default they take up 1 byte. So normally with the character type, um, you use char, char. Some call it car, others pronounce it char. I've had it across the board. It really doesn't matter. I mean, C++ is not a spoken language, it is a written language. So for example, here we say char greetings. We have these symbols here. That stands for an array of characters. And that's why I have used two examples which are both valid. So I can say greeting, hello. So we saw before normal text or something you want to represent as a string of characters. You can put them in between between quotation marks. And then the other way is char greeting, where we have the same representation split into an array of the individual characters as displayed. And then you'll notice this character here, which is appended. That's the symbol for a null character. Anytime in text we saw this the slash, where it's used to tell the compiler this is a special character and not actually should not be treated as the text we see, or the human readable form. So /0, that is basically a null character. Every character type or string in memory ends with a null character. Oops. Let me clear that. And then, so basically, the character types, you have the char 16 underscore t, char 32 underscore t, char underscore t, or the char range can be -127 to 27. That is for signed characters. And signed char goes up to 256, because from the range of 0 to 255 rather. So those are 256 characters. And then when you see the 16 or the 32, that char 16 is usually 2 bytes, or in brackets 16 bits, which has a range of 0 to 65 535. The 32 is a 32 bits with a range of 111 4111. That's actually 1.1 billion, and we don't need to go into the nitty gritty of that. Then to determine your system, because systems are different architectures, when you use the wchar underscore t, it's usually what is the widest supported on that particular implementation. If you're on a system that is not too happy about this, the 32-bit representation, then it will fall back to the 16 bits and so on. Anyway, then the characters also have modifiers attached to them. These modifiers are available to sign or unsign the characters. So you can have a signed char and an unsigned char, or whatever way you need the data type to hold. Then moving on, we have the integer types. This is a type used to represent whole numeric values, and they are actually strongly coupled with, you find them strongly coupled with modifiers, which alter the characteristics of the type. And these modifiers can be split into two main roles, which is the signedness of the type, or the size of the type. So for example, here we see int x is equal 10. So int is the basic integer type, but there's a limit to what an int can be. So to expand that, or to reduce memory usage, we can use the size modifiers to indicate that. So basically the signedness modifiers are signed and unsigned, and the default is usually the signed value. So this here we could simply say is a signed int of x, which is equal to 10. And then obviously the unsigned accommodates non-signed positive, can accommodate signed positive numbers. So the int x here, we can see unsigned int x is the same as above. So you, in this case, you don't need to use the word unsigned. Signed int x10, that's allowed, even though it's this, I mean, technically it's you'd have it from face value to be the same as what's above. But when dealing with certain figures and numbers, then especially um, I mean, when you use it in this form where you put a negative, that changes everything. So you cannot say unsigned int x and then put the minus there. It won't work because now you're out of the memory range which we spoke of right here, which is similar to for int as it is with char. Then the size sets the memory width of the integer, and the default is 16 bits wide on a 32 16 bit system, or on a 16-bit system. But on a 32-bit or 64-bit systems, it's 32 bits wide. And then you can use this construct with the int and use this, run that on your in your program to get the actual width of the underlying implementation. But generally speaking, let's for now we just pretend that any size modifier, if it is a short, it has a width of 16 bits. If it's a long, it has a width of at least 32 bits. And if it's a long, it has a width of 64 bits. And that is used since C++11. So short int 10 can be unsigned or unsigned short int, and it has a range of minus 32,768 to 32,767, or 0 to 65,535 if it is unsigned. Then you don't even need to say short int is equal to 10. You can just say short for example, short int x is equal to 10, you can simply say short x is equal to 10. That's valid. You don't need to use the int. But again, it's better to use, I prefer using the full method. It makes it more readable, and it just gives you better, consistency and better habits. Then here we have a long int where you can give it the same thing, and then long int. And you can see the range for a long int, which is a 32-bit figure there, which here you can see it takes you up to 4 billion. This is a 64-bit. I won't even go and try and say what that number is. But a good practice to start with signess, size. If you're using the signess, you're using the size and then the type. You normally want to start with the unsigned, with the signess and then the size, and then finally go to the value type, in this case, which is int. Now, we also have floating point types. The floating point types in general terms handle numbers with decimals. And basically, this is single precision number, 32-bit numbers. A double is a double precision 64-bit number. And then there is long double extended precision, which in general is about 80-bit. It's an 80-bit number. So it's basically used the way you would use an int, but in this case you just say float example is equal 3.2, or double example is equal 3.2, etc. And that's as far as it is for the C++ types. And then there's also a set of keywords we've just listed here. You can pause your screen as I go through them, and some are specified when they entered. You can see the char 16_t and char 32 have been available since C++11. Concept is joining in since C++20. The ones in bracket 1 have kind of there's a change in the implementation in all the versions of C++ versus the modern types. But basically, all the words listed here as key type, the keywords here, basically you don't want to use these for variables because they have special meanings within the inbuilt language. So avoid these. If you're saying like int x is equal to 10, you cannot say, for example, int return is equal to 10. That the compiler will not be happy with that. So, like I said, you can pause on this screen, go through them. You don't really need to have to remember this. The compiler will tell you if you're wrong or if you have a great C++ IDE. Check the previous videos. The IDE will catch these for you. So this is not something I would really worry about, but it's good to have an idea of at least most of them offhand, if not all of them. And then with time, as you use the language, they'll just become second nature, and you'll know what to not use and what to use. Then there's some identifiers with special meaning. You know, these are and preprocessor directives. These are we will be looking at these later, where we have like final override, which they do specific things which we won't touch until the time comes. And as it is with these other keywords, we shall be touching on them later on when we're actually using them. But next in the series, we'll be looking at the preprocessor directives, where we'll be looking at, we will come face to face with these keywords: if, elif, else, and if, defined, if not defined, define, etc., and def, include. You've already seen the use of include, and then there's line, error, pragma, and underscore pragma, which is been available since C++ 11. We will not need to look at this. We'll just specify what each does. And like I said, probably we'll see an example of if, elif, else, and if, and maybe defined, because the way you use them is all the same. So we will be explaining exactly what preprocessor directives are and how they work in your code. So that's it for this lesson for now. Great to have you guys with us, and it's great to be back as we carry on and finish and proceed with this lesson. So I'd recommend you guys share this tech episode, share this series with your friends and other people who need to learn modern C++. We're going to make this rather easy. Hit that like button, subscribe to the channel, and remember, when you subscribe, hit the little bell icon so that you can get notified when we upload these videos, because now we're going to resume rolling out this content. And not only C++, we have other languages coming up. We'll be talking about that very soon here on So Interactive. So great having you guys. Bye, and have a great evening. And